So here we have the JK flip-flop with asynchronous set. Asynchronous meaning that regardless of the clock, if set is 1, then Q will be set to 1 and Q naught is 0. Regardless of set or outside of set, we see that when there's a rising clock edge and J and K both 0, then it results in no change. When there's a rising clock edge, J is 0, K is 1, then it's a reset, meaning that Q is 0, Q naught is 1. Rising clock edge, J1, K0 is set, Q is 1, Q naught is 0, and finally, when there's a rising clock edge and both J and K are 0, the output swap, so Q becomes Q naught becomes Q, and the action is just called toggle. So if we go over and look at the code, this is represented in VHDL right here. Set is 1, then Q is 1, Q naught 0, and that's regardless of, again, of clock events or J or K. Then outside of that, we have the rest of the J and K represented here accurately. Then for the test bench, define JK as a component, create the signals for each, and map them to the component. Then we sort of cycle through each input value for various seconds, step through, and then we get a lot of varied results for the outputs to test each possible case. So we'll go ahead and step through real quick. Here's the wave. We have our inputs. I'm gonna just step through a few times and then go through and explain. So here, if we go outside of Q being undefined and look to where it becomes defined, here we see that clock equals 1, set is 0, so that has no impact on the output. J is 0, K is 1, meaning that it is a reset. So right here, J and K are now swapping. J is 1, K is 0, but because we haven't hit a rising clock edge, the change isn't implemented or reflected in the output. So we'll go ahead to where there is a rising clock edge right here. So as soon as the rising clock edge hits, J and K still remain 1 and 0 respectively, and Q has now changed to 1, Q naught has changed to 0, because when J is 1 and K is 0 and there's a rising clock edge and also set is 0, then that results in a set. So let's move forward and look to where set becomes 1 and how that impacts our function or output. So here we have set equaling 1, and that results in Q becoming 1 and Q not becoming 0. Even when there's a rising clock edge and J and K would represent reset, because set is still 1, that has no impact on the output. So set is still 1, and therefore Q is still 1 regardless of JK or the clock edge. So then here set becomes 0. After this, when set becomes 0, we haven't hit a rising clock edge yet, so Q still remains 1, Q naught remains 0 still. We finally hit a rising clock edge here, but J and K are in the appropriate have the appropriate values for Q to still remain 1, meaning that J is 1, K is 0, meaning set. Finally, we go here and we see that clock is hitting a rising clock edge, set is at 0, J is 1, but K is 1 as well, meaning a toggle occurs. So the output swap, so Q has gone, it was at 1, it now goes to 0, Q bar becomes 1. So those are all the different cases possible for the JK flip-flop.